Example, prove that the limit as x approaches 2 of 3x squared plus x equals 14. Because this is a proof problem, we will need to do some preliminary work. First, the purpose of doing the preliminary work is so that we can determine a delta. To do that, let's begin with the absolute value of f of x minus L. In the absolute value for f of x, let's replace it with our function 3x squared plus x. And for the minus L, L is the limit, which is 14. We can expand this a little bit and write this as the absolute value of 3x squared plus x minus 14, and that factors nicely. That will factor to the absolute value of 3x plus 7 and the absolute value of x minus 2. We need that absolute value of x minus 2 because we're finding the limit as x approaches 2. Now, notice that the 3x plus 7, that's the expression multiplied to the absolute value of x minus 2, is not a constant. The key here is that we are interested only in those x near 2, and for those x, we make preliminary assumption that we are only going to consider x within 1 unit of 2. So, for those x within 1 unit of 2, the absolute value of 3x plus 7 will have the absolute value of 3x, and we're going to do something clever with the 7. That is, write it as a difference of 2 terms. So that's the same thing as negative 6 plus 13. In the absolute value, let's group together the 3x minus 6. So 3x minus 6, we still have the plus 13. And looking at the 3x minus 6, it has a common factor of 3. So we can further simplify this as the absolute value of 3 times the quantity x minus 2 plus 13. The absolute value of 3 times the quantity x minus 2 plus 13, using inequality properties of absolute values, will be equal to or less than, we can write this as 3 times the absolute value of x minus 2 plus 13, and that will be strictly less than 16. Where did the 16 come from? Well, remember, we chose x within 1 unit of 2, and so whatever you pick for x, it cannot be more than 1. Let's just see what happens. If I put in 1 for the x, got minus 2, still times 3, plus 13. At most, the absolute value is going to be 1, but it has to be less than 1. So 3 times something less than 1 plus 13 will be less than 16. Back to the preliminary work. In this case, the absolute value of 3x squared plus x minus 14 will be less than epsilon, provided that our x minus 2 is less than the epsilon divided by 16. Notice at this time we have 2 restrictions. The delta must be the smaller of the epsilon over 16 and the 1 we previously chose. We actually have enough information now to write the proof. Now the proof. To present a proof, always start by writing proof. The writing requires that you write the hypothesis first. So, given an epsilon greater than 0, we're going to let delta equal, here's some more new notation, min for the minimum of our two choices, that was 1, and epsilon over 16. Now we proceed. If the absolute value of x minus 2 is greater than 0 and less than delta, then our proof follows that the absolute value of 3x squared plus x, that's the f of x, minus 14, that's the L, is equal to the product of 3x plus 7's absolute value times the quantity x minus 2's absolute value. And we know that that will be equal to or less than the 16. And for the delta, we'll write epsilon over 16, which equals epsilon. We've proven it. We found the delta. And so we conclude. Therefore, by the definition of the limit, we have shown that the limit as x goes to 2, 3x squared plus x equals 14.